Okay, I'm back with another stream. Hey, I've gone for a few weeks, had some stuff to take care of. But anyway, I'm back. So where were we? I was working on this Ecodocs build, and for that I had set up a small mapping between the actual microcontroller, which is Teensy 2.0, and the microcontroller I am going to use with the PCBs, which is a Arduino Pro Micro. There are a few challenges. These two aren't compatible directly with each other, but they use the same internal microcontroller. So we were mapping pins from one to the other. So that's why we are playing pin pong. Okay, so let's get started again. One of the things I want to do is, yes, so this is the pinout of the Arduino Pro Micro. Let me bring it out here. And then this is one of the same. It's not what I want. Yeah. So this should have some help with the mapping. Now, this particular one is also the Pro Micro. I don't want to use this. And we were just trying to figure out what we were doing. This is the data sheet. Right, so this is for the Teensy to be right. Okay, good. Let me just set it up in one way. Now, what do we want to do? So we have this spreadsheet, which I'll get to in a minute. But mostly we want to keep referring to these two diagrams and keep moving between one pin and the next, between the two microcontrollers. So this board itself has a different layout between the two options. Okay. Right. Let's see. Okay, this looks fine. Okay, perfect. Now, where were we? Let's bring this up a little bit. Yeah, so to recap for myself, the Teensy board is on the bottom here. Okay, the Pro Micro is on the top, and what goes into the PCB is a Teensy board. What I will be using is a Pro Micro board. So what I want to do here is try to come up with as few handware options as possible, and then get back to doing most of the mapping in software or firmware. So I might get to the firmware part of things today as well. Let me see where we were. So let's recap this a little bit. Okay, so you're planning to use on pin 24, we are planning to use raw voltage, say 6 to 12 volts. So for now I'll connect it to plus 5 volts, which could also be VCC pin here. Now the problem is that these ports, the data pins, we had gone through this right hand side of the board, and from what it seems we had completed the mapping. Okay, these are the Teensy names here. So A0 to 1, 2, 3, 4, 6, 7, 8, 9, 10. Right. So these map here. We don't use these in the PCB itself. So that's fine. Now what PCB am I talking about? Let me take a look at this. Right, so what I have here is an Ergodox PCB, and on this side we have a Teensy header. Okay, this is one of the microcontrollers that I'll actually be using. Let me bring it out. Right. Right, so that is the Pro Micro. It will have headers going into it like this. Okay, on both sides. So now, first thing to check is, does it physically fit in there? It should. Let me add the headers to the top first. I'm just trying to position it for now. No soldering yet. Right. So it kind of fits. Fit our focuses, yes, there. So it kind of fits, as you can see, physically. Okay, so now if I do this, it won't work because this is a different controller board than what the PCB is designed for, right? Okay, so back to our mapping. We'll just keep it out here for reference. Okay, let me switch back to the screen share. Right, so where were we? In this side, let me get out of the way. Right, so on this side we finished A0 to A10, and these are called on the Teensy, they are called these F names as well. So that's what the Teensy label is. Logical number is found by this row here. Then we have a Teensy name. So there is a label, there is a number, there is a name, and these are the 32U4 pins. 32U4 is the actual microcontroller inside the Teensy and the Pro Micro. That's the reason this mapping will hopefully work. So now we have to find equivalent Pro Micro names, right? Okay. Nice. So let's check the other side. What do we have here? So ground is ground, and it continues to, but it, oh man, okay. So ground cannot be ground in the Pro Micro as is, because pin 1 on the Pro Micro here is TX0. So that won't work. So internally we found, where are these names? So I thought I had found a source for looking at these names. between the two boards. Let's see where that is. Yeah, I'm hoping I won't need that hack. So where is yes, so these are those pins. I'm just thinking here, so if this is C7, I just need to locate this here, right? How do I find that? So from the point of view of this guy, where are these pins? Okay, so these two are ground, and I can't connect them, so these two have to be hand wired. So mapping type is either hand wire or header, right? So this will have to be hand wired, definitely. Right. So where is B0? I don't see a B0 here, which is weird. Okay, so this says it's TX0 21. Okay, B0 is RX LED. All right. Maybe I have to do that. So what I see here is that this B0 pin, which is here on pin 2 of the Teensy, here is available, just that it is on the RX LED. And if I go back here, this is how I'll have to, yeah, B0. So I will have to do a bit of surgery to remove this resistor and then solder that directly, hand wire it to B0 using something like this. This will fly off there and go into the pin 1 there, or pin 2 rather. I think that might work, so let me note it down. So this gets hand wire don't care about this Pro Micro physical pin numbers. I think these two are my main things here, right? So physical pin number, it is actually on RX LED. Not on an actual pin. Interesting. Cool. So that takes care of B0. What about B1? Where is B1 on this side? Just looking. Okay, B1 is on pin 15. Now if I keep trying to go to the actual pin, I would pretty soon have to hand wire everything. So I think I should do this mapping in 2 phases, which is what I had stopped at last time. So the first stage of the mapping is think about hand wiring everything, and then see how many of those hand wires I can get done by just changing the pin map or the pins used within software, right? Okay, so let's at least find the hand wire mapping. So where would I have to hand wire? B1. So B1 on this pin. Right, wait. So this is ground, and then yeah, so this is the issue, right? So B1 is on what is called as Teensy 1, and 10, 16, 14, 15. So what pin is this? 13, 14, 15, 16. 16. So this is actually pin 16 physical, isn't it? 4th from the bottom. 1, 2, 3, 4, which is 15. Physical pin and Pro Micro label. So Pro Micro label, I should write down correctly. So what's the Pro Micro label for this? There's the label. Is there? No. Okay, this one, B1, if I take it to this side, it is Pro Micro label is 15. Physical pin number is 13, 14, 15, 16. Okay, cool. Go down where this. Right, so in the second pass, I'll try to minimize these hand wires. First pass, I'm just sticking to hand wiring because at least this fits in directly, right? If I hand wire everything, I can just test it out as well if required. Fine. So what about B2? Where is B2 on the... Where's B2? I'm wondering what this 9 thing is. Should really read up on what that is. Anyway, B2 pin 16, B1 is pin 15. Okay, so label is 15. So this row is the label. This is the actual logical name. This is Teensy label. So B2 goes into 14. So physical pin number 14. And Pro Micro label 16. Yes. Yeah, it's have to be careful because it's a little bit of a confusing mapping. Pins move around a lot, and this is also a handler for now. Right. So this becomes B2. What about B3? It's this row. Starts on. So B3 is on pin 5, which is 1, 2, 3, 4, 5, right? So B3 is on pin 5, and here it's on 13, 14, 15, pin 15, physical pin 15. Did it crash? I'm wondering why this thing crashes. Weird, right? It's a lux. Anyway, I don't think anybody will make it to watch it, but I just want to get on with it anyway. Okay, if anybody is hanging out in chat or lurking, just say hello. It will be good to interact with some people. I see there are 3 or 4 people in there, but I'm not sure if they are bots or actual people. Unless you say hi, I won't know. Anyway, right, let's get on with it. So B3 is Pro Micro label 14, if I'm not wrong. I was hoping it won't be so confusing. So let me just quickly check it again. Pro Micro physical pin number 14 is label 16 is B2. Correct. Next pin up is label 14. Physical 15 is B3. Correct. Next pin up is label 15. Physical pin 16. B1. All right. Nice. Next is B7. Let's look for B7. Let's keep going. All right. Now I'm wondering if B7 is missing. So B7 seems to be missing in Pro Micro completely. Right. D5 B0. Weird, isn't it? One would have hoped they would give all of these pins for use, but okay, so B7 doesn't seem to be available. Don't know what to do with it. Seems to be not connected. Next one, D0. Okay. Come on, where is D0? There it is. Is this the same place? So D0 is physical pin 7 on the Teensy. It is physical pin number 1, 2, 3, 4, 5, 6. No worries. I'll just admire it for now, and then at least the hope is that D0 I can interchange with say D1 and then in firmware, and then be able to use a header. Okay, so this I'll have to handwire. How? D0. So what is D0 in? On the Teensy side? What am I looking at? Did I mess it up? Right. So B7 D0. So D0 is pin number 1, 2, 3, 4, 5, 6, 7. Correct. So 7 D0. Logical number is 5. Okay, that's fine. So where is D0 on which physical pin on Pro Micro? So that is 1, 2, 3, 4, 5, 6. This is physical pin 6. Okay. And what's the label on physical pin 6? D0? That's 3. Oops. See, these typos can be very costly. My reading is right. D0 is on 3. D0 goes to 3, which is pin number 6 physically. 1, 2, 3, 4, 5, 6. Awesome. Cool. Next up is D1. which is pin number 6. Sorry, pin number 8 on the Teensy. Logical number 6. Where is D1 on this guy? It's pin number 1, 2, 3, 4, 5. So physical pin 5. Logical. Okay, label is 2. I am reading this correctly. Yes. And this also has to be hand wired. I'm going to have to do 2 passes over this. So I think I went, yeah. So here what I did was I already did some firmware or header mappings, which means that I have sometimes used up those pins. So this will have to be done in 2 passes, right? So I'll have to kind of redo this side as well, just to get the first pass consistent, and then I'll move it to a second pass sheet where I'll try to just stick to the sheet and map things as much as possible. It might be possible to try and do this mapping by using some sort of a quick mapping script or optimization kind of thing, but for now I'll just do it manually. There is some certain fun in doing things manually and slowly rather than just rushing through it. Yeah, so next up is D2, which is label 7, logical number 7. It's fine. Where is D2 on? Cool. So D2 on the Teensy is pin number 2, physical pin 2. Again, hand wire, physical pin 2. What is it called? RXI. Yeah, so that's okay. RXI. Is this right? I think it looks right. So this is labeled as RXI on the, just check here. It's RX1, not RXI, I think. Yep, looks like RX1. Oh, it won't be visible there. All right. Next one. Next one is D3. D3 is pin 1 TX0. Okay. Pin 1 TX0 is hand wired. All right, this makes sense. What's next? What's next? All right, so C6, pin 11, C6, where is C6? Okay, I find C6 on label 5. So C6 seems to be on label 5. What's the physical pin number? 1, 2, 3, 4, 5, 6, 7, 8, 8, 8, 8. Again, hand wired. C7. Come on. Are you kidding me? No C7. At least I can't see it here. No C7, D5. Right, so there's no C7. do something about it later. Okay, so what I'm going to do is create a duplicate, rename it to say backup. We'll get to that later. Rename hand wire mapping. So part 1 of pin Pong is to finish the hand wire mapping. I want to go and undo this part and redo it again on the right hand side, simply because this stuff, right? Let me just get rid of it completely. Reason for that is, I think in the first pass what I learned was, if I try to do the correct mapping, it will lead to complications, because I'll be using pins which are actually on the other side, and it will be premature optimization. And I want to just take it a little bit step by step now. So this is all Teensy stuff. Can fill these two in later, but for now what I'll do is, so I'll concentrate on the Pro Micro label and Pro Micro physical pin number. Mostly I'll look for hand wire mappings everywhere, right? Okay, so we are up to the right hand side. So we did C7, which is not found on this guy, right? Cool. So I'm wondering if anybody I know will have done this kind of mapping before. I don't think so. I found a couple of articles that were talking about it, particularly on this website. Where did it go? So we are already using these. I think I should do a shout out for these folks at some point in time. So the point is, if we don't have enough pins, I will have to use pins which are available on the Pro Micro to substitute for the ones which are not available on the Teensy. No problem. Cool. Okay, let me get back. Anybody hanging out in chat? Maybe not. Cool. Okay, let's continue. So D6 is on pin 13 here is actually supposed to be D6, isn't it? But I know that, yeah, it's written here. So D6 label 11, D6 logical 11, A10 name, right? So what I want to do is look for D6 in the diagram here. I know D5 is over there. Where is D6? Oh, come on, D3, D2. Another one that is missing. It's not going well, I would say. This isn't on Pro Micro. And hence mapping is GPT. What else? What is next? What is next? D7. D7 I think exists. Right? So where is D7? There you go. So D7 is on pin 1, 2, 3, 4, 5, 6, 7, 8, 9. Physical pin 9. Label is 6. And this is a hand wire. Good. So we got that one. B4. Where is B4? Right, there you go. It's on pin 11. Right, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Right, so this is on pin 11 and label is 8. Hand wire. B5 is just below it, which is pin 12. Pro Micro label is 9. Wow. Okay, going okay so far. B6, now that comes the fun part. Right, B6 is here. B6 is on pin 13. Now, weird thing is, if I do this, 10, label is 10, which is this? Nope, yeah, this is 10. F7, do we have an F7? One, two, 3, 4, 5, 6. No, so this is 13, 14, 15, 16, 17, 18. Yep. Where is F7 now? Alright, F7 is here. It's 13, 14, 15, 16, 17. Physical pin 17. And wire. And what's the label for F7? A0. Alright, weird. See, this one in the previous version had used up here. I think here, right? A018. Yeah. So what had happened was, if I do this, yeah, okay. So this is the header. If I put it correctly, and I think I got the same result here, right? Pin 17 B6 is A0 header. Oh. Okay, I think this is just wrong. Okay, so here's how I'm reading this. Okay, so F7 is 13, 14, 15, 16, 17, 18. F7 is on 18. I had mapped it to, why am I calling it A5 here? Right, so it's A5, but it's actually, I should be searching for F7 over there, isn't it? Yeah, so this A0 thing had confused me back then also. And the Arduino numbers don't really matter, I think, in this case. So I should stick to these. Okay, good. So I think what we're doing right now is correct. So, pin 18 F7 maps to F7 A0. No, yeah, F7 A0. Am I right? I hope so. Cool. I think what I'll do is I will do one pass over this fully, then go back and check this in detail about what these numbers are. So I shouldn't get confused with these A designations. They seem to be not really specific. So this one I should just abandon. and look at this side, right? So I should go ahead and check what these pins are and where they lie on the Pro Micro. Okay, I think I'll do that as a second confirmation pass. No worries. Now pin 19 is F6, which is here. Pin 18 and where A1, 13, 14, 15, 16, 17, 18, right? This is F5. Next one is F5, pin 20. F5 is pin 19 here. A2, correct. And so we can avoid a hand wire only if physical pin on the Teensy is the same as physical pin on the physical pin on the Pro Micro is the same as physical pin on the Teensy. Okay, next up F4. Where is F4? F4 is just above. F4 is A3, pin 20, and wire. Sounds good. Next is F1. This is where it kind of gets messed up. So 13, 14, zoom it in a little bit. 13, 14, 15, 16, 17, 18, 19, 20, 21. 21 is VCC. So I can't use pin 21 anyway. And now I have to find where F1 went. And as I was hoping won't be the case, F1 is not connected, it seems. Okay, so I can't use F1. Not on Pro Micro. DVD. What is this one? F0. Don't think we have F0 either. I don't see it. Alright, so I don't have F0 either. What? Yes, so think for now I've completed one pass. I find 1, 2, 3, 4, 5 pins not connected. That's a problem. Cool, so I'm about at an hour into the stream with one pass done on the hand wire mapping. Now what I'm really hoping is that I won't have to actually hand wire the whole board. So if I can find replacements for these in a firmware mapping, then I can convert the hand wire into a header. So question is, how many hand wires can I convert into a header? So header would mean something like this. Go to the side view. Right, so this is a header. Right, so these headers just pass straight through. Okay, so if I prefer headers, what I will want to do is go in and check with QMK what are the names which are available inside QMK, because what I want to do is I want to take QMK names and use whatever is in these pins on the Pro Micro. Okay, so what I really need is a name or label, not label. So what is this? Right, so these things, right? I want to map, taking these, I want to know the pin numbers on both of these. Okay, so let me create a new sheet. Here what I want to start with is so what is this? Let's check QMK for a bit. Okay, oh, not your drawing. Yes, this is not the web page I'm looking for. Am I not logged in? Dash, I think. So I did set up a GitHub org just for this project. Yes, so here I am, and what I want to do is go into QMK firmware, look at layouts, pick any for now. Ergodocs. No, not that layout. Keymap C. So this is the part I was talking about. So key code, these are key codes, and that's the layout, right? So ultimately we want to get these key codes. Now question is, where are the pin mappings in Ergodocs? So what is this? Oh, this is keyboard layout editor. That's not what I want. So let me orient myself a little bit into how QMK is organized. Okay, so I don't want to go into layouts because layouts are about key layouts. Okay, I think what I need is to check keyboards, Ergodocs, easy. Okay, that's worth a shot. These are matrix positions, layouts. Okay. Instead of that, can I get something about AVR? So where do we have any Teensy specific boards? Okay, there is a Teensy 3 one here. Just have a look. Right, so board.h should have the IO pin assignments. Yep. Good. So what I am looking for is this is the actual QMK, right? I think it does not have what I'm looking for. S32DU. Right, so I think I should search for Teensy 2. I do remember seeing the Teensy 2 mapping somewhere. So let's see how it is configured for a regular ergodox. Is that even in here anymore? Yep. Okay, there's a boards list. So this thing uses Teensy 2. So here is the header for Teensy 2. Oh, this is a layout, isn't it? Yeah, I think matrix row pins and matrix call pins is what I'm looking for. So the main point I'm trying to figure out here is whenever I use QMK, I'll have to define matrix row pins and matrix column pins. So maybe the way I should be looking for this is take matrix row pins and matrix column pins from a firmware which was written for the ergodox and change those to whatever falls under the same pins or equivalent pins of the Pro Micro. If I do that, the same firmware, I mean that mapping will at least tell me if I can reuse some things as headers and remaining ones I can keep hand wiring. So if I want to use the same mapping as the firmware, I'll have to hand wire everything or pretty much everything and find replacements for things that are missing. Right? Changes to how you wire the keyboard. AVR pins used for columns, AVR pins used for rows. Column to row, column is anode, row is cathode. Right. Awesome. And I'm not screen sharing. Brilliant. Okay, so what I found here was the two defines that I should look for is matrix row pins and matrix column pins as used by ergodox firmware, and then find the corresponding AVR pins between those two controllers I'm wanting to use. Cool, so these are AVR pins, right? Let's bring the sheet up. So AVR pins mapping, right? So AVR pin, what am I doing? AVR pin Teensy physical Teensy 11 Pro Micro So Teensy physical pin, Teensy label, Pro Micro physical pin, and Pro Micro label, right? Right. It crashed again. Brilliant. I'm wondering why Pretzel lock screen keeps crashing. Any idea, anybody? I'm not sure if anybody's around. Right, there seem to be 5 people around, but I don't know what they're up to. If you're in chat, say hello. Right, back to work. Yeah, what I was checking was in my handware mapping sheet. There. So what I'm calling as Teensy label is actually AVR pin. And this isn't AVR pin anyway. So I think what I'm discovering is these fellows are all AVR pins. Yes. Good. Oops. Nice. And what do I want to do here? So I wanted to build a kind of reference cheat sheet where I take these things, I can read off the equivalent numbers between these two. So what are the AVR pins used here? So B, C, D, E, F is what I think they have. AVR pins B, C, D, E. So I wanted to check here which AVR pins are actually on this. So these are the ports, right? Port B, C, D, E, F. B, C, D, E, F are the ports. This, not this, not this. Instruction set, not yet. Cool. So mostly what it seems like is U4 B spike spikes. All right, so this sheet works for a lot. Don't care about the revisions and fine. All right, so B, C, D, E are the ports, right? Just read up 8-bit bidirectional I port. B0 to B7. So C has just 2 ports. Only bits 6 and 7 are present in the product of pinout. Okay. Port C serves the functions and special features of the device. So C6 and C7 should be the only ones present. But how come this? Gosh. So this thing uses C6 and C7, which have some special meaning here. And so B and D are full. E has only 2 and 6, right? Also serves special features. Page 81. So page 77. What? 77? What are they even talking about? Weird. What 77 thing are they referring to? Come on, if you're referring to a page, shouldn't that page be in the document? Or maybe I've just looked at the summary and I should look at the full one. Cool, I'll look this up later. So I should look at B0 to B7, C6, C7, D0 to D7, and E to E6. Then there is F0, F1, F4, there is no F3. It's 2 and 3 not. Cool, I think that makes sense. Now what I'll go ahead and do here is go from this datasheet. So I like datasheets because they are supposed to be the authoritative information about that particular microcontroller, right? So microcontroller is the internal brain of these boards. So if you look at things from the microcontroller's point of view, it serves as a sort of a useful reference, because so the board manufacturer may have called things differently than, different board manufacturers may call things differently, but I would want to standardize my terminology on the chip manufacturer. That is this data sheet. So B0 to B7, let's start with that. So B0, B1, and this goes on till B7, right? What next? So apart from B0 to B7, we have C6 and C7. C6, C7. Okay, what else is there? D0 to D7, that's the other data for which is full. D0, D1, D2. Okay, that makes D7. And ultimately we have E to E6, not D2, E2 and E6, right? What else? 0, 1, 4 to 7, 0, 1, 4 to 7, F0, F1, 4, 5, F6, F7, is that right? So 2 and 3 are missing, 1, 2, 3 is missing, 4, 5, 6, 7, right? All right, so these are the AVR pins which we can expect to find in any of these boards. Let's see where they are on the Teensy. I want to note down physical pin number, so I will have to refer to this diagram. Yes, so physical pin number of B0, where is B0? There is no, okay. B0 is pin 2. Label is what is on the physical chip, which is B0. Not bad, not bad. This looks good. So B1, where is B1? Should be the next one. 3. Wait. B0 is pin 2. B1 is pin 3. B2 is pin 4. B3 is pin 5. Is that right? 2, 3, 4, 5. 0, 1, 2, 3. Let's just double check. 0, 1, 2, 3, 2, 3, 4, 5. Now B4 is 15. 5, 6, 15, 16, 17 are the pin numbers. 15, 16 and 17. Where is B7? Right, so B7 is pin 6. Let's just check that. B7 is pin 6. 15, 16, 17 are 4, 5 and 6. 15, 16, 17 are 4, 5 and 6. Right. Where is C6 and C? Where are C6 and C7? They are here. 11 and 12. Wonderful. D0. Where is D0? Aha, there is D0. 7, 0, 1, 2, 3, 7, 8, 9, 10. D3 is pin 10. D3 is pin 10. Right. Where is D4? Is there no D4? Really? There is a D4. Oh, okay. So D4 is underneath here. So I think what I've done here is, since I have used the pin numbers only on the sides, this physical pin number doesn't really make much sense on the Teensy, because the Teensy has these extra 5 pins here, right? Which are VCC ground and reset, VCC ground and reset, right? So if we ignore these pins, then there is D5 and D4 on that side. And yeah, cool. So I'm not going to redo my pin numbers because I like these. It's fine. So the labels are correct as per the AVR names. Okay. So what I'll do here is D4 and D5 are not that. D6, where is D6? D6 is pin 13, I think. 6, 7 is 13, 14. Okay. Right, where are E2? I thought we had E's in, yeah, so E, because E6 is here. Why is E? What could there been E6? I thought E6 was not supposed to be present. Yeah, E2, E6, sorry. Where is E2 then? Is this supposed to be E2? I think so then. Interior is PE6. Where is interior? Yeah, PE6. AIN0, INT6. These are interior pins. And I don't care about them. Okay, so I'll skip E2 and E6. They are present on the Teensy, but I don't care. Now comes F. So F0 is starting from here. 0 and 1, 23 and 22 is 0 and 1. 23 and 22. 4, 5, 6, 7. 4, 5, 6, 7. Right down on that side. 4, 5, 6, 7 is. Cool. I think that's, so Teensy labels are correct as far as we know. Good. Whenever they are present. Onto the Pro Micro. So what's happening here is, in the Pro Micro side, so let me just get rid of this for now. I don't want to check this again. Yes. Right, so here is the Pro Micro. Not bad. Okay. Right. So on the Pro Micro side, what I'm trying to do is also list where these data pins, the AVR pins are. So where is B0 on the Pro Micro? Didn't I just see it? Yeah. So that is RX LED. Yeah, the physical pin is RX LED. Awesome. B1 is on 13, 14, 15, 16. To 16, but label is 14. Okay, I think this should be right. Correct. So B3 is on 15, which is marked as 14. 13, 14, 15. Okay. B4. Where is B4? B4 is marked as 8, but is pin number 11. Yep, that's 11. B5 is pin 12, which is marked as 9. B6, where is B6? Pin 13, which is marked as 10. B7, where is B7? Yeah, is this the one we didn't find? Yep, B7 is not on Pro Micro. Alright, so B7 is actually in C, not connected. C6, where is C6 on this thing? C6 is pin number, okay, it should be possible to see it from here. C6 is pin number, C6, C7 is pin number, oh, C7 is absent. Awesome. Right, so C6 is pin 8, label 5. Pin 8 label 5, pin 8 label 5. Nice. C7 is not connected. D0. Where is D0? Label 3. D0, D1, D2, D3 should be these, right? D0, D1, D2, D3. Is it or is it not like that? Fine, quick check. D0 is physical 6, label 3. Label 3, physical 6. Level 2, physical 5 is D1. Label RX1. RX1 pin 2. TX0 pin 1. Okay, D3 is done. Where's D4 now? Label 4. So D4 is the one which was underneath in. That's what it is. It's don't care. U1, U2, U3, U4, U5. U5. D5 is U1. Okay, so D4 is present nicely on pin number 1, 2, 3, 4, 5, 6, 7. D4 is on pin 7, label 4. Pin 7, label 4. D5 is present on TX LED. That's the one, TX LED. No label. Yep. D5 is on TX LED. D6, where is D6? Thought that we had D6. Doesn't seem to be. D7 is label 6 in 1, 2, 3, 4, 5, 6, 7, 8, 9. 9, 6. Where's D7? Oops, this is D7. Costly mistake averted. Right. So closing that. Oh, been live for about 1.5 hours now. So I'll take a very quick break. Once I finish these mappings. So D6 seems to be not connected. Actually, is this what I found here? D6 is not on Pro Micro. Okay. E2, E6, are they here? E6 and E2. I don't find E2. The E6 seems to be present. So these things have special meaning, right? So one thing that I'll want to do is check out what that special meaning is. So special meaning shouldn't mean that you can't use them as regular ports. But, anyway, so this is 12, 11, 10 and 7. It's not E2, it is E6. F0 is not present. F1 is also not present. Yep, these two are not connected. 4, 5, 6, 7 is 4, 5, 6, 7. So pick it up from here. 4, 5, 6, 7. Thirty, 14, 15, 16, 17. Yep. All right, so this is done. Let me format it a little bit better. We are done. Are we? E2 is not connected. No, not connected. Good. And did we have E2, E6 here? Yeah, no E2, E6 here completely. So these, they're the internal, it says. E6 is internal. Okay, don't care. Truly don't care. Good. So here is what I want to do. I want to sort this thing by Teensy pin, find the Pro Micro pin, and read the good. So since I'm done with the mapping, I'll take a quick break here. When I come back, what I will do is I will try to use this reference chart as a way to move this here back. Right. So what I'll do is I'll use this as a reference chart. Start with the Teensy physical pin because I want to run a header down through, right? See what is on that physical pin in the Pro Micro. All right. And then use that. For example, in firmware, if I want to use Teensy's physical pin 2 as the physical pin 2 of this, no, it won't work that way. Select all. Right, so I want this to be pin 2. Similarly, this is pin 2. So if I switch B0 to D2, then I can run a header. Yep, that's the kind of steps I want to do. Let me try another one. So I take pin 3. Is there a pin 3 here anywhere? No. What is pin 3 on this guy? It's ground. Yeah, so what will happen is some of these pins I won't be able to reuse. or run headers through. Some of the pins I'll be able to. So with this chart, I should be able to do that mapping on top of the hand wire mapping. Don't care about this column. Yes. All right. I think I'm set. Let me take a quick 2-minute break and get back to the optimization side of these things. All right. I'll be back in 2 minutes. Okay, I am back. Right, so what were we doing? We wanted to finish off. What I wanted to do was use this pin mapping that I was working on to simplify the or minimize the hand wiring that I need to do. So what I'm going to do is I'm going to start with physical pins and find equivalent pins, mapped pins that I can use. So I don't want to disturb this sheet, so I will duplicate this, right, and optimized mapping is what I'm looking for. Why is the music not playing? Right. Cool. So now pin 2. Right, how do I do this? Conditional filter. Oh. So B. Okay, I'll just do it manually for now. So pin 2, I can sort by this. I think this makes sense, right? Right, so microphone 2. Why does this have S0E3? Oh man, did I mess this up? No. Why do I have A3, A2, A1, A0 here? These are supposed to be labels. Did I copy paste this wrong? Whew. Wow. Unbelievable. Okay, so these have to be reversed. Got this, put it here. What? This copy pasta is a bad habit. So labels are all these. Let me quickly check this again. So physical pin TX LED, RX LED. Some are not connected. So let me go run through it this way. So if this physical pin has this label, I think we should be okay, right? Let me quickly do that. Physical pin 1. One is TX0, 2x RX1. 3 and 4 are ground actually, so they don't connect. 5 is 2, 6 is 3, 7 is 4, 8 is 5, 9 is 6, 10 is 7, 11 is 8, 12 is 9, 13 is 10, 14 is 16, 15 is 14, 16 is 15, 17 is A0, A1, A2, A3. After that it has VCC, reset, ground and raw, which I will use but don't figure in the AVR pin mapping. Cool. Sanity check done. Let's start using it. So sort physical pin to B0. So I should just keep reading what is on here because I don't care what this was, right? I want to map it to something different as long as that pin itself is available. Okay. Right. Physical pin. So in the optimized mapping, starts at a copy of that. So this is ground in Teensy 2, right? And ground I will have to hand wire into the ground pin of of the Pro Micro anyway. So 2 is B2, so 2 is B0, and instead of B0, if I use, so instead of B0, if I use D2, I should be set. This Pro Micro's pin 2 is D2. Okay, and which is present in that's good. So was pin 9. So pin 9 I can't use then again. Okay, I think I'll have to take multiple passes through this. All right, so how about mapping B0 to get this here, right? Teensy. How should I note this down? So instead of so on the Pro Micro side, what am I connecting it to? Physical pin 2, which is D2. All right. So Pro Micro physical pin 2, what does it map to? I'll still need that, so I'll bring it out here. Yep, to RX1. Dude, what's happening here? Did this. So I want to use T2. Okay, so the mapping I need to create is B2 to D2, correct? Yep. So before I go to optimized mapping, now here itself, so what I'll do is I will, what is Teensy name? A business. Okay, so I will add one more column here, which is, so before I look for Pro Micro label, B0 was connected to RX LED. Oh, RX LED. Yeah. So instead of being connected to RX LED, it is now connected to RX1, or which is the Pro Micro label, and this is header. So for this to become a header, I will have to make this Pro Micro label RX01 and pin number 2, which invalidates this. Yes, that's what I want to do in the first pass. Cool. Next mapping. Pin 3. There is no pin 3, there is no pin 4, so can't do anything with those. 5. Pro Micro physical pin 5, which is label 2, is D1. Right. Okay, so I have to go this way. So pin 2 I have remapped. Pin 3 and 4 I can't remap because, so pin 1 I cannot remap because Teensy's physical pin 1 is let me do it this way. So there will be no AVR pin, but Teensy physical pin 1 is actually ground. Correct? Pro Micro physical pin. There's no Pro Micro physical pin for this area. No, that's fine. 24 is VCC, right? Got it. Now, if I sort by this, 1, 2, 3, and 4 I'm missing. And their Pro Micro labels are so the Pro Micro labels are what? For 3 and 4, ground, as expected. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 16, 17, 18, 19, 20. Right. Now I want these entries. '21, '22, '23, '24. And what are their Pro Micro labels? VCC, RST, VCC. Ground and raw. Got it. Cool. Now this makes sense. Let's go. So 2 and 1 I couldn't map because it's ground. 1 will be hand wired to. So 1 is ground, 1 will be hand wired to what? Pro Micro pin 3 and 4, right? Pro Micro label is ground, pin number is 3. That's where it will go. It has to be hand wire, cannot be anything else. It could be 2 other pins, so Pro Micro is like totally wasting pins for no reason, but can't do anything much. Right. So I'm going to get rid of these things. They're a little distracting, particularly when I don't care about this as well, but I'll keep it for now. Don't care about the Teensy name column. Right, got it. So these two are done in the optimized mapping. Okay, optimized mapping, hand wire. So pin 1 will have to be hand wire because it's ground. It's hand wire to pin 3, which is also ground. So I could just do a jumper. Pin 2 here. Pin 2 here is running a header to this side, and that's because it is mapped to RX1 label, but internally what is it? So instead of Teensy label, right, so this Teensy is labeled correctly, right? So here I want to make sure there is a mapping that is, so I have mapped B0 into something, Pro Micro AVR pin. That's what it should be. Yep. Pro Micro side AVR pin. So this was not an AVR pin, but on the Pro Micro side, this AVR pin is what? Come on. D2. So it is D2 on the Pro Micro side. That's why D2 was nullified from here. So this is Teensy label, which is Teensy AVR pin. I'll not call it label for now. Why not? Oops, did I? I should do. Clearing my throat should be done on mute, I guess. Right, let's go forward. 2 is B1. Sorry, pin 3 is B1. And if we go to the mapping, 3 is ground, so can't do anything. 4 is not grounding. Pin number 5 is D1. So what is pin number 5 here? Okay, start here. 3, 4, lost cause. 5, B3. And what is 5 here? 5 is D1. So optimized mapping for this 5 is D1, which is Pro Micro label 1, 2, 3, 4, 5 is 2. Pro Micro level is 2, 5. Conditional formatting coming up. Right, so what I want to do is, in case anything in this column is the same as column H, then do a conditional formatting. So format, conditional formatting. Is equal to How do I do this? If this is equal to this, then do conditional formatting. Let me do it with 1 and then no. C3 format cells if is equal to H3. The formatting to do is make it yellow. Right. Ignore. Ditch. How do I check if this is equal to this? I think I'll have to do it manually for now. Very interesting thing to learn. Let's see. Google Sheets, custom format, 1 colon equal. No. Highlight cells using conditional formatting based on another cell value in Google Sheets. Let's take an example of a student score and see how we can highlight the names of the students based on the scores. Okay. Select cells you want to highlight student's name. In this example, click the format option, conditional formatting, single color. The format rules drop down, select the custom formula is the value of formula field, enter the following formula is equal to B2 less than 35. The formatting style, select this formatting that you want to apply. Okay, click on done. Okay. Checks the condition when it's checking type 3, it checks the condition and so on. Awesome. That's a little bit but right. So click these cells, go to format, conditional formatting, disable teams, custom formula is equal to H3. Right, I think I know what the problem is. Format, my formula is not correct. C3 equals H3, C3 equals H3. Yes, there you go. Done. Right. Okay, fine. So I know that these two are done. Fine, maybe I'll stick with this for some time. Dark mode be damned. Now we are on to pin 5 was done because these two are ground anyway, so I couldn't have done anything. Pin 6 is not on Pro Micro, right? So can we use the areas pin mapping? Teensy pin 6 is D7, right? What is pin 6 here? D0. So if I use D0, I should be good. Before that, I have to invalidate D1, right? So I've used D1 there, hence I can't use actual D1. No, so I've invalidated RX1 2 because RX1 2 is used here. So 5.2, where is 5.2? I have to invalidate this because I have used it. That's fine. So pin 8 cannot be mapped to pin 5 because pin 5 is mapped to pin 5. Simple. 6 is possible to map to D0, which is Pro Micro label 3 and pin 6. Yes. Is that right? 6.3. Awesome, awesome. On the Pro Micro 6 is D0, so if I use D0, I'm done. And 6.3 is used, so I can't use it directly like this, which was a handwire anyway, so it gets invalidated. Let's see what happens. This is not valid anymore. Good. Seems to be going well so far. Anybody out there in chat? Please say hello if you're around. Okay. Pin 7. On to pin number 7 of this mapping. Do I need that? No. So pin number 7 here is D4. So if I map it to D4, cool. So if I make pin number 7 as D4, I think it should be fine. So is D4 available? Yeah, D4 is available. So D4 is U5, so D4 is available here, pin number 7. So here pin 7 was D0, so D0 will be mapped to D4 now. All right, cool. So this will be 7.4, optimized mapping for this is 7.4. It's not invalid anymore. This is header. Pro Micro Physical 7, where is that? Right, it wasn't mapped yet. Makes sense because the D4 wasn't used on the Teensy side because it's on the side. Useful. Good. So we mapped another thing. So D0 becomes D4 now. So this is D4, right? Am I right? D4, 7-4. Nice. Okay. What's the next Teensy pin? Is 8, which is D1. On the Pro Micro side, 8 is C6. Can I map it to C6? Is it available? C685, is it available? Yes, it is available, but then this gets invalidated. Awesome. Next, so as you can see that as far as possible I want to retain headers, right? Seems to be going well so far. Let's see. Now 9 was earlier going hand-wired to 2, so that is not available. Let's see, pin number 9. Teensy pin 9 is D2 and Pro Micro pin 9 is D7. So 9, 6, D7, let's see. D7, 9, 6. Header. Nice music. Cool. That sounds good. Any issues there? So was 9-6 being used earlier? 6-9. D7. This gets invalidated. Five, 8 got invalidated earlier. Nice. 10. So physical pin 10 is D3. Physical pin 10 is E6. Teensy level E6. Yeah, that's don't care. Totally available. Cool. So physical pin 10, so D3 goes to E6. If it is available. This is on 10-7, right? Good, this mapping makes sense. 11, pin 11. So 10-7, was this mapped in a 7-10 anywhere? 10-7 was not mapped. Where is 7-10? Right, so pin 7-10 was not mapped because E6 is on the underside of the Teensy and was not used. Great, so we got 2 unused pins used in this case. I just have to check if E6 is available. I think it should be. So these are special pins, right? So I should check them. Pin 7 was unmapped earlier, right? Now on to 11. Physical pin 11 is C6. So it was being used as C6. Physical pin on the Pro Micro is B4 and it's on 11-8. Let's do that. So this is B4 and is on 11-8. Let's see if 11-8 was being used anywhere. Pro Micro label 8. 8-11. This gets invalidated. Going well so far, apart from Pretzel Rocks, which keeps crashing. Anybody in chat know why it keeps crashing? It's kind of annoying. Okay, maybe for later. Let's keep going. Two, 3, 4, 5, 6, 7, 8. Yeah, I think this is the main thing, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, looking at 12. So pin number 12 on the Teensy was C7 earlier. Pin number 12 was C7. 12 here is B5. So B5 is 12, 9, and I'll map it like that. This is B5, 12, 9. No, these are not handline, these are header, header. Hey, there seem to be a bunch of people in chat, or viewers, this thing says, users in chat, but nobody's speaking anything. So if you are in chat, please say hello. I'll love to know where you're from, or if you watch other streams, what are your interests? Let me know. Okay, pin 13, the other side. Right, pin 13 is D6, and on the Pro Micro side, pin 13 is B6. Okay, 1310 is B6. Optimized mapping becomes right. Hold on. Teensy logical number, Pro Micro label, Pro Micro AVR pin number, right? I'll add that column here. So this went to pin 13 B6. So in optimized mapping this becomes B6, and label, right, maybe I can switch these around. So pin 13 is 1013. Okay, B6 1013, B6 10 13. That invalidates this guy. What's the shortcut for this? Alt Shift F5. Fine. So I should not retain it like that, right? This is header, and this is fine. Good. All right. So why am I doing this? I think it makes sense to remind myself a little bit. So I want to use a Arduino Pro Micro in place of a Teensy 2.0 in the in this interesting PCB, which is half of an ergodox, there are some other. So I could not source a Teensy 2.0, hence I trying to mod the PCB so that I can drop it in here like this. I mean, sorry, not mod the PCB, mod the firmware, that I can drop it in here like this, and for the most part it should work. Maybe a little bit of hand wiring might be required. Okay, so that's the intention. And I realized that since I'm okay, I'll come to that later. So we're done with pin 13. What is pin 14 up to? On the Teensy, pin 14 is D7. On the Pro Micro, pin 14, sorry, here. Pro Micro pin 14 is B2. 1614, B2, 1614. Let's map it. And this should be okay now. Was pin 16 being used anywhere? 1614. Label 1614. Was this being used as 1614? No. Ah, there. Okay. So in the optimized mapping, label 16, pin 14. 14, 16, right? Pro Micro label 16, this gets invalidated. No worries, I don't need it anyway. Label 16, yep, gone. Awesome. Pin 15. So on the Teensy side, pin 15 is B4. If B4 needs to get mapped, it should be pin 15 is B3. 14, 15. B3, 14, 15. Let's do that. B3, 14, 15. And now this is a header. Forgot the conditional formatting on this side. Format, conditional formatting, single color, apply to range. Custom formula is equals O3 equals J3. Right? And yellow, done. Label 14 now gets invalidated. Pro Micro label 14, where is label 14? It's already gone. Cool. Pin 15. Nice, not bad at all. So B4 becomes B3. Right, so pin 16 is B5 on the Teensy side. What's pin 16 on the AVR side, on the Pro Micro side? B1, so B1, 15, 16. Let's map it. B1, 15, 16. header, and ready. 1516 should not be present in here now, right? So these two not going to get used, maybe, yeah. So these are invalidated. Don't hand wire them. Hmm. $17 is B6. What is 17 here? A0, F7. So F7, A0, 17. F7, A0, 17. No problem. Think F7, A0, 17. Header. This goes away, but this gets invalidated. Pin 18 is what? Pin 18 is F6, A1, 18. Let's do that. F6, A1, 18. This is fine. But this goes away. A1, 18 goes away. 19 was F6. Now 19 on this side is F5, A2, 19. This becomes F5, A2, 19. And this is header. This is fine, but this goes away. Pin 20. Pin 20 was F5. So pin 20 here is F4, A3, 20. So this becomes F4, A3, 20. Header. Cool. Okay, still no one speaking in chat, but yeah, if you feel like, say hello. I think there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 people in chat apparently. Say something, folks. It'll be fun to talk to you. Yeah. Right. So now comes 21, 22, 23, 24. These aren't really connected, so I can't use them. But I have to map F4, F1, F0 to something, right? Or not. So one of the conditions is I should be able to map each of these to something, isn't it? So from the Teensy's point of view, it is using all of these. This and all of these. So I do need to map these to something, because I will have to use the same number of columns and rows in the matrix, right? Oh wow, I'm not screen sharing, so this is weird, sorry. In case anybody was wondering why I'm on the side, I just forgot. Right, so what I've done so far is, on the right hand side, all of these got converted to headers, which is great, less hand wiring. Problem is these can't work as headers, right? And this just got invalidated before I forget. Okay, so Pro Micro's pins, a lot of them are getting used nicely. So since these two are ground, I can't make a header out of this, but B1, B2 can go to B1, B2 elsewhere, isn't it? But those are gone. So I'll have to change them to something other than B1, B2. on this side. Right. Okay. So these are open. I'm just going to remove these formattings. They need to be mapped and these still need to be mapped. This is gone. Right. So I think this is a good checkpoint to say that all of the headers that I could put in have been put in. Let me just go check one by one if any of these are available. F4 is not available. F1 should be available. Okay, F1 is not on Pro Micro. F0 is also not on Pro Micro. If I look up the AVR pins, F1 and F4 are, F0, F1 are not connected. So I have to find replacements anyway. So now what I should do is, in the optimized mapping, what is mapped is Pro Micro physical pins 2, 3, 5, 6, 7. Okay, so let me just highlight here Pro Micro physical pins which are mapped. So let me just sort by this for now. 2, 3, 5, 6, 7, 8, 9, 10, 11, 12. 2, 3, 5, 6, 7, 8, 9, 10, 11, 12. 2, 3, 5, 6, 7, 8, 9, 10, 11, 12 are all mapped. So I will highlight this with like a light gray. So these are gone. So grays are mapped already. These two are, pin 1 is not mapped. Interesting. Because pin 1 is ground there. Okay, fine. Pin 4, because it's ground here, it's still not mapped. Okay. And I could use something other than 3 and 4 here, right? So this could be either 3, 4 or something else as well. Doesn't need to be 3. Actually, it should be all true. They should all be grounded, right? Yep. $23. So what are all the ground pins? Three, 4, 23. Okay. So I would say these are used because 23. There. So these are all used. 3, 4, 23. I should actually connect them that way as well. 3, 4, 23. Right. 3, 4, 23 are all used. what pins remain? Sorry, on the other side, 13, 14, 15, 16, 17, 18, 19, 20. Then 24 is also used. There we go. Now, I'm not sure if it's actually used, but it's raw here and VCC there, so I can't use it anyway. But it's not a data pin, so that's fine. What is remaining is VCC and RST. They are spoken for, they cannot be used as data pins, right? So there is no data pin left except one. Ouch. I have these fellas left. Yes. RX LED and TX LED I didn't use, so I will need them. Okay. These two are also spoken for because they have to be connected to VCC and they have to be connected to reset. Is not really reset, but not a data pin. So they will get connected somewhere or the other. Let me hide the not connected ones here and blanks. Okay, so 3 pins remain. 1 TX and RX. 1 RX and TX LEDs. B0, D5, D3. Any of those. B0, D5, D3. So how many are we missing? This is madness. I need 5, but I have only 3. It's not cool. What can we do here? I think one issue is I will have to look into a second pass on this, which checks whether. So I need to find replacements for F0, F1, F4. B1, B2. Mark those as red. So I should be able to cover for 3 of these, but these 2 not being present and then those 4. So now that's going to be a lost cause, right? So I can map some of these into, so I should be able to cover for 3 of these, isn't it? What are left? So there would be 3 hand wire. Right now there is no hand wire. What's happening? Right, that's one hand wire. That's it. So so two possibilities. One is through firmware. Okay. So one thing I didn't take care of right now is how is the expansion going to work. So if the expansion is going to work by an IO expander, then I have to accommodate for all of these, right? However, if the Teensy, so if I'm going to use 2 Pro Micros, one on each side, then what I can do is I can use less number of rows and columns on each of the Teensys. So that will be a second pass. Optimized mapping, if I were to use just one Teensy, is kind of not possible. So is that right? So if I want to use just one Pro Micro, I will need 5 more pins to be mapped. I can map only 3. Physical pin 1, auxiliary, auxiliary. So I can do 3 of them, but I will not be able to, I will be left with 2 hanging, right? And that doesn't work, because if I want to just use the Pro Micro, a single Pro Micro in place of a single Teensy, I will need 5 pins more, but I have only 3 pins more. So it's not going to work. Yeah. I mean, I could solder pins directly to the let me have a look. And these things are so tiny, I don't think I'll be able to solder any wire directly onto the chip's legs. Nope. Nope. Yeah, it's too tiny. Not sure if I can show it on camera, but it is too tiny to be able to solder anything onto the chip directly. So although the pins are there, because they're not connected to any headers, I won't be able to use them, and that's bad. So now what happens is comes phase 2, which I think I'll not get into today. So what I did was today I finished the mapping purely hand wiring based. One thing which was not clear was that enough, right? So I had these TBD 3 and 4 5. So these 5 were anyway TBD even after all the hand wiring, and that carried over to the optimized mapping, where I was able to cover for most of the pins except these 5. Right? So in case of so the next phase of this Teensy to Pro Micro transition is, let me explain. Okay, let me move to the side cam for a bit. So here I have one of the PCBs, the right hand side PCB, one Teensy, which usually connects to the left hand side PCB, all right, as through a TRRS cable, which goes like this, and in comes an IO expander on this point, the MCP 23018. If I go that route, I should be able to use just one Teensy. However, I can't use one Pro Micro instead of the Teensy, because internally it's addressing via the expander all of the other parts of the matrix, right? So it is a wide matrix, many rows, many columns. So the number of rows is 1 2 3 1 2 3 4 5 rows, 6 7 rows. SW0, SW. Right, so there is an SW0. So what I'm trying to check is, on this PCB, how many rows and columns are there in the matrix. So what I see here is this is SW0. sure if it's visible. There, SW0. Right, so SW0 is a row. There is SX0. Let's see. SX0, SX1, SX0, SX1. Okay, if I use the center pins, then if I use one switch here, it's SW 1, 2, 3, 4, 5, 6. Good. Okay, so consider this as one row. 1, 2, 3, 4, 5, 6. 1. So there's 1. There's 1, 2, 3, 4, 5, 6. Okay, so that's row 0. And there's row 1, row 2, row 3, row 4, row 5. So that's 6 rows, right? And 6 columns. 6 rows and 7 columns because it goes from 0 to 6. So 6 rows, 7 columns. Okay, so 6 rows, 7 columns on one side and 6 rows, 7 columns on another side, right? Because this one starts from 5, 7 and goes till 5, 13. So if I were to cut down the number of columns and rows, so what I have to figure out is where are these rows and columns mapped, and if I were to then use 2 independent Pro Micros. Okay, let me back up a little. Both sides need to be scanned when the keyboard is operating. Now, one way to do that is use one controller to scan the whole matrix. Since this matrix isn't physically connected to this one directly, it's connected via a TRRS cable, which through the expander. So the cable plus the expander directly maps the data ports onto the scan lines of the rows and columns here on the left hand side. So either I use a TRRS cable and an expander. I can't use that because then I would need 2 more ports here to really complete the mapping, right? So I'm missing 2 ports. That's just a matter of it's the same microcontroller, but Teensy gives you more ports than the Pro Micro, right? And that's just a fact which I can't get around. So what I am going to do is use another Pro Micro on this side instead of an IO expander. The way that will work is I will take this. Let me see if I can open this. Yeah, kind of play my chance with that one. Don't have a scissor here, no problem. So imagine this is here already, right? And if I take this out, I can actually attach another Pro Micro here, like this. It will go in reverse because ultimately it's the right side up here, right? So it will go like this and here. Right, so you see that on this side, on the left hand side of the keyboard, I can put a second Pro Micro, which I do have right here. So the reason I bought 2 was because I knew that the number of pins may not be enough, and hence I will have to use 2 Pro Micros in one keyboard. So what I want to do is tie these 2 together in a 2-sided setup, figure out how many data ports that we'll use because I don't have too many. So this one would scan this half of the keyboard, this one scan this half of the keyboard by being tied together as a primary and a secondary, and they will still communicate over a TRRS cable, but the IO expansion will happen without the, so this will have firmware in it, right? It won't just be, okay, so I'm not sure how that actually works, because if this, so will this Pro Micro see the whole matrix or not? I think it won't. My hunch is this one will. So what I'll do is I'll read up on this a little bit, look into the guts of QMK, and figure out how QMK actually works with the 2 Pro Micro setup. Okay, so just to go back to screen share a little bit, Lily 58, right? So Lily 58 is one keyboard which uses a 2 Pro Micro setup. Lily 58 QMK. Is that, I have these already, is it? So let me search for keyboards Lily 58 readme. Let's read this. Right, so this is a split keyboard which has 2 Pro Micros on the left, one on the left, one on the right. Okay, connected by a TRRS cable, plugged in on one side. So kind of ideal setup for me. This is what I'm going after. Now, all I'm trying to say is I want to replicate that setup on this PCB. Okay, so this is the Pro Micro. It has an optional OLED, which I'm not going to use. So there is keyboard supported by PCB Pro Micro, PCB case data, build and certain make instructions, complete notes guide. Right, so readme is enough for that. Where's Linux? Isn't rocking. Config H. Oh, sorry. Now what I want to check is where is the how do I check for the matrix.c, right? No. So if I use I2C, get rows from other half over I2C, right? So what this is trying to do is I2C master start, master write, read, slave offset 1. Okay, so from what I see, it's the primary side of the Lily is talking to the secondary side over an I2C bus, or there is a serial transaction to kind of do the same. It's just passing buffers then. Matrix scan, okay, I2C transaction, serial transaction. Yes, 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 yes. All right. Columns and rows. Okay, these are for the actual layouts, not what I am looking for right now. Okay, where is that? We had found matrix row pins. I'm going to find matrix row pins in this directory. QMK Lily 58. Okay, let's see if I've pulled this down before. I had done QMK. Okay, no problem. I'll pull down QMK now. So I have maybe I can just stick with this for a bit. So go into master, search for matrix row pins in this repo. So this would be in each and every one, a lot of them, right? Matrix row pins and maybe 58. 1 rev1 config. Okay, there you go, there you go. Wiring off half, that's exactly what I was hoping for. Wiring of each half. Got it. So wiring of each half here uses, so these are the number of data ports I need. Okay, for instance 6 rows 10 rows 6 columns. Instead of that I can use something different. So there's 60 keys total. However, nice. So there is 1 2 3 4 5 rows and 6 columns, 5 6 or 30. So 30 on one side. Now I need a little bit more than that. Hence, if I look at QMK firmware on the, sorry, not this side. So where is the, there is no orthodox. Oh, there is. Where is the original orthodox? Weird. Totally weird. Look at, okay, look at orthodox, easy for now. It is, but right, has RGB indicators, LED, matrix features, fine. Now what I'm looking for is keyboard config.h. So in there is there a config.h. Matrix rows are 14, matrix row per side is 7, columns is 6. No problem. These matrix row pins. Okay, I'm going to do this on the terminal, much easier. Git clone. Okay, that should get me QMK. Cool. I was hoping some folks will be in chat and we can at least maybe answer some questions. I might get some suggestions, but I guess not today. So next time I'll announce it a little bit beforehand so that people can plan for it, plan for joining. Maybe that's a good idea. Okay, clone is done. Get in there. Keyboards, Ergo docs. TZ. Now git grep, not that guy. No matrix opens. Long shot. Okay, unused pins. Argodox.ez.c. Let's open it up. Teensy 2MD. See PWM and ports to see when ABC in Teensy 2MD. Okay. Yes, so this won't work for me, right? Yeah, this is too low level in the sense that, okay, I think one major thing I'm missing is I'm not able to figure out which firmware I would use as a base. So many maps, half keyboard. Config H seems good. (18 by 5). But that doesn't make sense. Let's look at Teensy. So matrix C has some things. Values, default values, sector values, matrix row, columns. Yeah, so this MCP 2318, 23018 won't work for me. So should I use the Lily firmware? So now here's the point. I think I should use a Pro Micro, two Pro Micro setup firmware, and just use the correct ports. So if I'm able to take a 2 Pro Micro setup, connect the matrix. So apart from the, so I know the, so because I've done the mapping, I know where the lines go. So which part of the nice. So because I have a mapping between Teensy on the ergodox and a Pro Micro, so I'm kind of virtually putting Pro Micro on the ergodox. However, to really take it to the 2 Pro Micro setup, I will have to check whether there is, so some ports will be used for the I2C communication. Those I will have to not use for the matrix, key matrix, and then take the other ports and map them to the PCB's matrix. The bits and map them here. Okay, so from where I see this going, so there is something called ergo done. What is it? Algorithm modified with resolved components recent value uses a spark on Pro Micro and 15. Okay. Yeah, this doesn't work. Okay, let's see. Going back to the ergo keyboards. Now I want to check which is the closest one. I thought there was an ergodox version which uses 2 Pro Micros. Maybe not. Ergo done uses an expander, so that's not for me. Not that. Ergo dash. Ooh. Sounds good. Pro Micro Admiralty for so feeding the ergo dash uses the correct setup. Does it? Six by 1, 2, 3, 4, 5, 6, 7, 42. I think this might work. 5 plus 7 is 12. Matrix to opens matrix. Okay, so where are the I2C pins? Yeah, so RGBDI pin. Serial pin T0, T3, backlight, which I like, because I'm thinking of adding a backlight to this version of the keyboard. Cool. So the Ergo Dash is a possible base for this keyboard. Not bad at all. What else? Ergo Done I thought was useful, but it seems to use an expander. Nope, that won't work. Easy isn't the one I want because it still uses a mass-produced version of that. So this doesn't have the E2 Pro Micro setup. Infinity also. Infinity 2 keyboards need to be flashed separately for the left and right halves. For my changes in each half. This has 2 halves, but I think it still uses the Teensy, if I'm not wrong. Oh, MCP 23. Nope. Ergosaurus, never heard of this before. And a Pro Micro driven Alice clone PCB supports. Yeah, but this is not a split board. Yeah, I think. Okay. Ergo slab, a split Ergo 5.6 keyboard with hot swap sockets and a heap of thumb keys. Pictures, yes. Two PCBs, 2 middle PCBs, 2 Pro Micros, nice. All right, so this is another useful base, but I think I want to stick as close to the docks as I can because I'm using its PCB. Travel and people are weird, man. Ergo Taco. Awesome. Okay, so let's assume that I'm going with the Ergo dash R1 config. Yes, so it looks for pins 1, 2, 3. So I just want to count how many pins I have right now. 1, 2, 3, 4, 5. 6, 7, 8, 9, 10, 11, 12, 13, 14. Do I have 14 pins? Then call it a day. Time to count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 17 pins. I have 17 pins plus 3 more. 18, 19, 20, 20 pins. Really? Doesn't seem right. Yeah, so okay, cool. So summary, it seems that if I use something like the Ergo Dash as a base, I should be able to, right? So what's the matrix size here, right? This is 5 by 7, 5, 1, 2, 3, 4, 5, 6, 7. Really? So that's 35 keys, but maybe not all used. So I can't change the matrix size, isn't it? So I will have to stick with how many 0 to 5, that's 6 by 7, 42. So 6 by 7, so 6 plus 7 is, God, so this is right. I think I'll have enough. So what's happening here is, instead of one full matrix, what's happening is I have 2 halves. So wiring of each half becomes simplified. Instead of getting 14 by 6, instead of 14 by 6, I have 7 by 6. So 7 columns, just like this one, and 1 extra row. That's pretty much all it should take. Okay, I think I will close for now. Hey Raising, thanks for dropping by. Cool, yeah, thanks for saying something. You're the first one to chat in today's stream. So what I'm doing is, I'm building an ErgoDocs keyboard. I have 3 constraints. One is, I was only able to source a few parts which were locally available. One of the constraints was the ErgoDocs originally uses a Teensy 2.0 microcontroller, and I couldn't source that. So instead of that, I chose to get a Pro Micro. I'll show you. This is an Arduino Pro Micro controller. Okay, it looks similar to the Teensy but has a different pin layout. So in today's stream, what I did was, I came up with this mapping between, right? So Raising, The Teensy 2.0 in the middle is what this PCB uses. Okay, this PCB. Okay, you can't see it because it's green screened. This PCB. So it uses a Teensy 2.0 here. And since I don't have a Teensy, I have to use a Pro Micro. And this spreadsheet I made is mapping pins of the Teensy into pins of the Pro Micro. So what I'm trying to do is drop the Pro Micro into the same socket, into the same place on the PCB, use as many pins as possible. So the highlighted ones you see are just straight through pins, and I'm left with a few choices to make after that. So inherently the Pro Micro has far fewer pins, let's say 3 fewer pins if I'm not wrong, than the Teensy. So I can't use one Teensy for the whole keyboard, so I have to use one Pro Micro for each side. Sorry, I can't use one Pro Micro for the whole keyboard. So what I've done is I've looked at another keyboard which actually uses this setup, which is this one, an Ergo Dash. So this uses a different PCB, but keyboards are almost all the same internally, which is it has a matrix of keys and a controller which scans the matrix and generates a key code. So QMK just works on that principle and allows you to say, hey, here is my microcontroller, here is how you communicate with it, give me a file which I can flash onto the microcontroller, right? So what I'm trying to do is start with a keyboard like this, which uses 2 Pro Micros on each half, right? Each of these halves, which you won't see very well right now. So start with the Pro Micro on each side, use this base file, compile it, flash it onto 2 Pro Micros, connect them, test them. What I will have to do is, since I'm using a PCB which is different than the one which is used in this keyboard, I will have to map or modify the pins, the pin assignments of the keyboard, and those pin assignments are found in here. Okay, with me so far. So it says matrix row pins and matrix column pins, right? In the PCB I have 6 rows and 7 columns on each half. So I will add one more row pin, and that will bring the total up to 6, and keep 7 column pins. Which pins to actually use is already decided by my spreadsheet, right? So I can take these D2, D1, D0, D4, C6, C7, so on. So I think I'm done with the hardware mapping part of the or the mapping part of the exercise. And in the next stream, what I'm going to do is start modifying the QMK firmware for this setup that I've come up with. I will most probably use the Ergo Dash, this keyboard, as a base, add my pins here, recompile or compile this firmware. Maybe I'll have to rename it because it isn't Ergo Dash anymore. Flash that firmware onto each of my Pro Micros, test it out. And if that test works, then I can just get to soldering and I'll have my keyboard. So that's the plan for today's stream. This is pretty much it. Hope I answered your question, Raising. Thanks for dropping by. So Raising, you're saying, thanks for explaining, great project, thank you. I am just an enthusiast who's building my first keyboard. I did do a lot of electronics, robotics kind of work many years back, but yeah. I have just started streaming, so this is actually my 3rd significant stream. And what I do plan to do is not just take one project, but multiple projects over different streams. So current project is this keyboard. I actually need a keyboard, so I'm building one. Once this is done, I'll move on to some other project. So, but it'll be based on mostly weekends because I have a day job during the week. So what I'll do is I'll set up, so I am on Twitter. So catch me on Yoda_droid on Twitter. Just use this. Right. So if you follow me there, I will announce when I'm going to stream. Mostly it'll be around this time. So if this works for you, please join next time, and I'll talk more about next phases of the project, right? So you also say Do you stream regular and have you any schedule as I'm interested in these embedded stuff as I'm learning myself? Wonderful, wonderful. So one of the objectives of streaming in the first place I have is to talk about some of these things so that people who are new or wanting to pick this kind of stuff up can ask questions, and it allows me to have a bit of an interaction, and this interaction helps me learn these things as well. So for me it's a hobby, but if you want to get into this kind of work, there are some other streams which you can follow as well, and I'll recommend some of them on my channel page. So if you go there, you will find other streamers whom you can follow and pick some of this stuff up as well. I think one tricky part here is, depending on which level of the embedded stuff you want to get into, you will find a lot of keyboard streams which are just taking a pre-built PCB, just soldering it, concentrating more on the cosmetic aspects of the keyboard, which are interesting, no doubt. For example, what type of switches to use, what type of case to use, whether to lube the switches or not. So if you're into mechanical keyboards as such, then some of those streams might be for you. But if you're interested in going deeper into how the embedded stuff is built, from the microcontroller to the circuit diagram to programming the microcontroller and then interfacing it with something, in this case switches, then I would suggest you follow some streams which are non-keyboard oriented, right? And I can recommend a few to you. So follow the stream from right, so go follow Knobcat. She's a wonderful streamer, has been doing embedded stuff for a very, very long time. And in case you, they also stream on Sundays, might be streaming right now, so maybe we can rate them. If you're interested in this, I would say you're welcome to join my stream. There are fewer streamers who work on embedded stuff from the circuit design upwards, and I'm hoping more such people will join. I am actually not super deep into embedded stuff myself, but I like to program hardware, and I also want to kind of pick up some side projects which are a little different from my day job. Hey, you just came from Knobcat stream. Awesome. So yeah, she was part of the inspiration that led me to pick this stuff up. And mostly I needed a keyboard, so I thought, okay, why not stream it as well, right? So wonderful. So I think you have the right people. Next Sunday I will stream again, so hope to see you back. I think best will be if you follow me on Twitch. You will get notified whenever I go live, and follow me on Twitter as well, because I'll probably post a few hours or at least a day in advance that I will be streaming, so you'll know. I don't have a very set schedule right now because I'm trying to juggle things. It's just early days for me to stream, so very happy to have you here. Okay, let me see. I think you might have posted a link. Let me see if the moderator view comes up somewhere. Where is it? Okay, you say we'll be present for your next stream. Thanks, Raising. I think it'll be fun to have you, and it'll be wonderful to interact with a few people. Last stream, a lot of people from the local keyboard community here in India, which is where I'm streaming from, and they joined the stream and they helped me out quite a bit. And one thing I'm trying to do is kind of become part of this chill programming, chill streaming community. People who are interested in interacting a little bit to maybe help people who are just trying to pick this stuff up, because there are a ton of resources on the internet, but sometimes it's a little difficult to ask questions and get answers about these topics, right? So I benefited a lot from following people who do this kind of work on Twitch, and I'm trying to do the same for kind of pass on this stuff. So for now, I'm going to end the stream. Thanks for dropping by. if things go well, I will look a little bit more into the software side, which is the QMK programming side in the next stream. And if things go really well, then we may be able to flash one of these little chips next stream and test it out as well. Okay, so thanks for dropping by, Raising, and hope to see you in next stream. I'm curious to see who all are streaming right now. Okay, thanks. You say have a good day. Thank you. Let's see if we can rate somebody. All right. Who is streaming? All right, I have a few. So there is. No. All right. Okay, awesome. So we're going to rate Eric.dev. He's also a wonderful streamer. I think might be doing some. Okay, right now he's doing Rust programming in GStreamer. So he does a bunch of work on the NVIDIA Jetson side as well. So wonderful streamer. I interacted with him interestingly in three weeks back, sorry, and we were working on something interesting. So he's a great inspiration for me, so I will try to say hello by raiding him. Please join the raid if you're around. Let's go and see what Eric is doing. Okay, so thank you everyone who saw the stream, joined the stream. If you're seeing this later, do drop me a message at Yoda_droid on Twitter, and hope to see you later. Bye bye.